my name is Robert Juhasz and I'm a data scientist. I would like to talk about my final project called Contract Analytics with Natural Language Processing. I'll walk through my motivation, the dataset, the Transformers model library. I'll talk about transfer learning and do a short demo of my app before I talk about next steps. My motivation is that I work with commercial contracts on a daily basis, and I wanted to use natural language processing and open source machine learning models to analyze commercial contracts. I want to go through a pipeline where I can scan in a document, run it through a machine learning model, and then extract information out of that agreement, such as a governing law or other clause types. I use the contract understanding Atticus dataset, which is basically a manually labeled data set using more than 500 agreements and creating more than 13,000 labels by legal experts, identifying 41 different clause categories. This has been done by the Atticus project. They used Edgar, which is a government data set with publicly available commercial agreements. I also use Transformers, which is a state-of-the-art open source library by Hugging Face. Transformers can use both PyTorch and TensorFlow. It has more than 30 pre-trained model architectures and more than 12,000 different models in the library. Some of them are very complex, have more than 1 billion parameters, and many of them support multiple languages. There are also 14 pipelines for automated execution. Pipelines make it really easy to run through the whole process, but if we need more customization, we can take those steps separately and run through those. There are many tasks that are offered by these models. I use summarization, token classification, and question answering. The Atticus project also applied transfer learning, and they custom trained this data set. Transfer learning is a very effective way of training a machine learning model where you can take a large publicly available data set and do pre-training, and then you can take the results and do further training on a small domain-specific data set. This really reduces the need to manually label a large amount of data. When we look at the model performance, the Atticus project actually used 3 different pre-trained transformer models, and they used the area under the precision recall curve as metrics for identifying the best performing model, which was the DiBerta extra large model, which is the latest and the largest of these 3 models. You can see the blue curve is representing that model, which reached the highest precision rate, 44% at an 80% recall rate. You can also see that the performance is varying based on the different clause categories that we are trying to identify. Finally, I would introduce the application that I have built. This application is basically deployed in Amazon Web Services. It can read in a scanned document, run through the optical character recognition, and then do analysis on the text. So when we open the application, we can upload a scanned PDF document, and then it will run through the optical character recognition and recognize the digital text. And then once we have this raw text, we can click on the Analyze Contract button, and then it will run through 2 machine learning models and generate a summary of the document and also extract named entities, which is called named entity recognition. Those can be organizations or locations or other entities in the document. In my next steps, I'm planning to improve the model performance. I also would like to apply my own training of the data to further improve the performance. I would like to implement batch processing of contracts and also implement a database to store the results. For this, I used mainly Python. I use Tesseract OCR for the optical character recognition. I use the Transformers library for machine learning. I packaged everything in a Docker container. I used Plotly Dash for displaying the application, and I deployed everything in Amazon's cloud, Amazon Web Services. Thank you for your attention. Feel free to reach out to me at my contact information.